Hello everybody and welcome back to this tutorial. And in the previous video we saw how we can connect multiple PCs and multiple targets to our threaded server. We saw that it worked with two targets. We were able to manage two connections at a time. We were able to switch between those two sessions without closing the actual session and actually running the commands as we need on a target as we need. Right now there is a little bit of a problem in our program, as there really isn't a proper way, or we didn't code it yet, a proper way to close the program or the center itself. So what we want to do is, first of all, we need to use the flag that we coded in the server function. So let me just show you. If I zoom this in and go to my Python programs, reverse, delete the compilation builds, ls once again, and if I nano my threaded.py, you can see right here that, let me just go down here, we coded the stop threads to break right after we actually set it to be equal to true. As you can see at the beginning of the program, we set it to be equal to false. Now we need to use this actual variable that we set in order to properly close this thread. So we can do that in our outer while true loop. So this is our session part right here, which is coded. Now we need to add another statement right here. So for example, else if command, and then the first, or just the entire command. We don't need to use the first letters. The entire command, if it is equal to exit, so this will close the program. And how we can do that? Well, first of all, let's imagine we have a bunch of connections and socket objects connected to us. So we need to close each of those targets or each of those socket objects before actually closing the program. How we can do that is we can iterate over this targets list, which is containing the socket objects from the targets, and we can close them one by one. So for target in targets, so for some variable target, don't confuse this target with an actual target that we parse to the session itself. So for target in targets, what we need to do is simply just target.close. And this will close all of the socket objects with certain connections. And after that, we need to close our own socket object that we coded right here. So here it is. We need to close it right after closing all of this. And then, after we do all of that, we can select our stop threads variable to be equal to true. What this will do is then this will be set to equal to true. Our while true loop in server function will go from the beginning to the end, then it will run onto this line. It will check whether stop threads is true. Right now this statement will be fulfilled, and then it will break out of this server, closing this function. Now make sure that this line right here is critical for this function, s.setTimeout1, because if you don't have a timeout, this part right here, which is the accepting part, will try to accept forever, and our server code will actually be stuck on this line, and it will never go to this line right here. Therefore it will not be able to close the program properly. It will be stuck on this accepting the connection and waiting for someone to connect, and then it will never reach this line. But if you set the set timeout to be equal to 1 second, for example, it will try to connect or to accept for 1 second. If nobody connects, it will just go right here. It will skip this, it will pass, it will go check this, and then once again 1 second, and so on and so on. So we set the timeout there. We set the stop threads to be equal to true now. And all we want to do right now is join the thread of our server. So t1.join, join it to the main program, and then we can break out of our while true loop, which will close our program. So simple as that. Let me just check this out right here, whether we coded everything we need. Now also, one more thing is, let's say we want to close a connection with just a single actual session. So you can see right here that we no longer have the actual Q command to be specified as closing the session, and we are not really able to close one session at a time. But that is something that we want to implement. So let's go in our shell part right here with the function that will communicate with a single session at a time, we want to type here else if command equals to exit. Now don't confuse this exit with the exit that we just coded right here. This exit is the exit that corresponds to the server part or the center part, command and control center part of the while true loop, and this exit function right here is the exit command that corresponds to the while true loop of our shell function, or of our function that will communicate with a single session at a time. So what we want to do is simply just close the actual socket object for that target, and we want to remove it from the list, so targets.remove, and we want to remove the target. We also want to remove this target from the IPs, so IPs.remove IP. And then we can break out of this loop for our shell. So let's make sure we got this correct. If we specify exit in a certain shell, for example, we communicate with Windows 10 and we no longer want to be connected to the Windows 10, we just type exit, it will close the socket object, it will remove the socket object from the targets list, it will remove the IP address from the targets list, from the IPs list, and then it will go back to our while true loop of our center. So basically, if you specify exit, you will not be able to connect back to Windows 10 as long as they don't run the shell once again or restart their PC. And if you specify Q, you will be able to actually communicate with other sessions without closing the current session. So it might sound a little bit complicated, but you will get used to it. It's really not that hard of a program, so don't worry. What I wanted to do right here, let us just check out whether we coded all of this correctly. Now there is a part that we need to code in the reverse shell as well, since if you remember, we don't really have any command called exit in the reverse shell. So let us go right here. Let me just go right here. Reverse shell.py. We need to nano it, so nano reverse shell.py. And right here, we go to our part in the while true loop. And here, if command or else if command equals to exit, what we want to do is simply just close our socket object. Let me just check it out here. How did we name it? Where is the connection function? Here it is. So sock.close, we want to close it. And we want to break out of this program. So simple as that. I believe this should work. Let us save this right here. Or no, we don't really need to do it. We have it right here. So sock.close is already specified there. Let us remove it from here. All we want to do is just break out of this loop. So we don't need to close the socket object right here. Let's save this. And now we need to compile it once again. So wine root.wine drive C Python 27 py or scripts py installer no console one file, and then the reverse shell.py. Okay, so the USB drive is already plugged in. I will use USB drive to actually deliver it to the actual Windows machine. So it is all okay. So I forgot to close the previous reverse shell. Let us close it with Task Manager, delete it from here. I also didn't close it with the Windows 7, but it doesn't really matter. Yeah, it doesn't even matter. We will just name it differently. Okay, so let us go right here. The compilation hasn't finished yet. Okay, so here it is. I will go to my this directory and I will rename my reverse shell to shell.exe. Now, you don't have to do this. I'm doing this because my Windows 7 machine, so I don't bother to actually close the reverse shell from Task Manager there. So I will just name it differently, and then I will move my shell or copy my shell to the var www.html, which is my Apache 2, and copy the shell to the actual USB drive, which is media, root, and then Kali Live. And then what I can do is I can delete all of these compiling directories, and I can start my threaded.py. Then I can unplug my USB drive, So I can actually get it to my Windows 10 machine. Here is my shell.exe. I run it. Everything seems to work well enough. I go to my Windows 7 machine. I go to my Internet Explorer, refresh the page. Here is the shell.exe. I download the shell.exe for my Windows 7, so click on it. Save on desktop. And we can actually run it as well. Click run. Since we downloaded it from the internet, it prompts us with an actual warning, which is usual for every exe file you actually get or download from the internet. We can see our Windows 10 machine has connected. Now we're waiting for our Windows 7 machine, and then we will actually test out whether our program or whether our connection can be established and closed at the same time. So we connected back the Windows 7 as well. If we just type here targets and enter session with Windows 10, who am I, works. Let us press Q to not close the session, but to actually make session go in background. So, and now session 1, who am I, also works. So now if I want to go to session, let's close the session with the actual Windows 7 PC, so ipconfig should be 192.168.1.6. This is our Windows 7, and if we just type here exit and type targets once again, you can see that I no longer have here the actual session 1 with my Windows 7 PC. And if I want to enter my session with the actual Windows 10 PC, I can still do that and execute commands as much as I like to. You can run screenshot if you want to. You can run any other commands that we used from the previous sections where we coded our reverse shell. And if I want to close this session with the Windows 10 as well, I just type here exit. And if I just type targets once again, you can see we no longer have any targets right here. But right now what we want to do is also exit the center itself. So we want to close the program. And if I just type here exit, you can see the program closes properly as well. So we coded everything successfully. We can close sessions, we can manage sessions, we can switch between sessions. We can also properly close our center program. We can actually do anything we want with our targets except multiple connections. All we need to do is code a very useful function, which is rather similar to some functions we already have, and I will show you in the next video. But this function will allow us to actually run a command and send it to every target that is connected to us. Now imagine you have 200 PCs connected to you. You don't want to go to each session for each PC and run certain commands one at a time. You want to have some function that will send that command to every PC, and then they will execute that command. That is the basics behind running, for example, the DDoS attack. You send to everyone a command to run a certain SYN flutter or pinging program or anything that you upload to them, and then they run that at the same time, and that's how they can crash web servers and other hosts. So we will see how we can do that in the next video. Hope you enjoyed this one, and I hope I see you in the next lecture. Bye!